So this is a rainbow bridge, and pretend someone is walking on the bridge. So let me choose a good color. What's the color is good? Okay. So if someone is walking on the rainbow bridge, so you can feel that different location on the bridge. You can feel the slope is different. So see here the slope like this. Here the slope like this way. Here is more flat on the top, very flat. And here steep. And here steeper. So for the common sense, you can feel like on the top is flat, so we say no slope, or we say slope equals to 0 on top. And on the right hand side or left hand side of this top, the slope will have some number, right? Mathematically. So you can feel there's some slope here on the right hand side and some slope here on the left hand side. Now I'm going to talk about mathematically. Mathematically, we use n to represent the number of the slope. And this direction, we say slope is positive. And this direction, we say slope is negative. How do we decide is positive slope or negative slope? So let me erase something here. Erase this one and erase this one. Okay. So when I'm talking about the slope, I start to draw the arrow from left to right. So from left to right, this going up. From left to right, this one going up. From left to right, I will say this flat, right? Okay. And from left to right is going down. From left to right is also going down. Okay. So that's how we decide mathematically. When it's going up, we say it's positive slope. When it's going down, we say it's negative slope. And when it's flat, the slope is 0. Not positive, not negative. So that's the first important information. On the real life, you may feel, oh, there's some slope, no matter from the left hand side or from the right hand side. We always think about it's a positive slope, but mathematically, we would like to include the direction. So always from left to right, and if you going up, then the slope is positive. If going down, then the slope is negative. So that's first thing you have to keep in mind. Okay, so next, let's keep going to next page here. So pretend that's the slope. Again, you can see that the slope at different location supposed to have different slope. Okay, here and here, 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 you have different slope, and all everywhere on the rainbow bridge supposed are different. The slopes supposed are different. Now, let me choose some examples. For example, we choose some point on the rainbow bridge and pretend that's the slope for a particular point. A slope for a particular point. Okay, so today the most important thing is how we calculate the slope. For example, if you have a rainbow bridge around here, then we are talking about the slope, right? We talk about the slope for the particular location. So if you are talking about a particular location for the slope, and if you are on a curve, then how to calculate the slope? So you will learn how to find slope for the point on the curve, not today. Is when you learn calculus. Okay, so today I'm not going to teach you how to find the slope for the curve. So if we have a curve and you try to find the slope here, try to find the slope here, you cannot do that. I'm not going to teach you right now. You are not ready for learning that. So today, basically, I can only teach you to find the slope if you have a straight line. Why? It's easy to find the slope for straight line because for straight line, their slope on each point are the same slope. Why is always the same slope? It involves a similar triangle concept. We talk about similar triangle when we have chapter 10. This also extra information for you. But anyway, I am not going to talk about similar triangle concept for you. Just believe me, if you have a straight line, then on the straight line, every single point, they have same slope, not like a curve. Different location have different slope, and it makes sense. So that's why I don't want to confuse you with too much information right now. Okay, so if you agree with for the straight line, okay, let me erase. the slope on the slope on the point of a straight line are all the same. Okay, so that's very important because the slope are all the same, so we can talk about and we can develop some formula. And when it become curve, we base on the straight line formula, we can apply to when it's curve. But how can we apply that? That's when you can learn calculus, then you can understand. Okay, so that's an important message first before we can start. So right now, we are not going to talk about the slope for a curve. So let me erase the curve here. So pretend we have different straight line sections here. And each line section, we have different slope, yes. But for each line, there are same slope. Okay, so for the red color, we have slope. For the yellow color, we have different slope. And for this blue color, we have different slope compared with different line, right? And here we have green slope and orange slope. And what's this color? Wow. What's this color? I don't find the color here. That's fine. So I will use this one. Okay. And the purple, I have the slope. And here. Now I would like to tell you if this is flat, so slope is 0. And what happened to if you're vertical? If you're vertical line, the slope is undefined. Okay, undefined we say is very big. Or we use this symbol, infinite big. Why is that? I will explain. Okay, if we later, I will explain that. Not right now. I would like to talk about the formula first. But in the beginning, we are not going to find the slope for the vertical line because there's no number you can calculate, so no formula. And for the flat, yes, we can calculate with the slope because the number is 0. Now, other than these two green slope, how we calculate the slope? So that's the next thing we want to talk about. So far, there's no formula yet. It should be easy, just concept. Okay, and start from right now, I'm going to talk about how we really calculate the slope. So let's take a look the next page. Okay. So next page, see we have a curve. When we have a curve, basically I said that there's no way I can calculate a slope for u. So basically, we can only calculate the slope. We pretend from A to B is a straight line. Well, it's a straight line. Pretend is I cannot draw well. Okay. So basically, we pretend it's a straight line from A to B. So we connect become a right triangle. Okay, it's a right triangle. Well, and from B to C is another right triangle here. And from C to D is another right triangle. D to E is another right triangle. So what we did is we try to calculate the slope for when we go through the graph, kind of confusing. Okay. So I don't have ruler to make it a straight line here. So yeah, so pretend you understand it's a right triangle. Okay, let me make a dot so it will be easier for you to understand. Okay, so that's right. Make a dot is more accurate than I do a straight line. Okay, and then we make a dot. Okay. So you have the right triangle here. So this number 1, number 2, number 3, number 4. So basically, we pretend this is a straight line, this is another straight line, this is another straight line, this is another straight line. So they have different slope. Slope 1, slope 2, slope 3, slope 5. Okay. Now, how we calculate the slope? Because the slope here and the slope here are the same, right? Slope here and the slope here are the same. So you simply choose any 2 points, connect, there will be a straight line. Now, so the definition of slope we use m as a symbol, and then rise over run. What it means? Means you want to calculate. If you run 1 step, how many steps you supposed to rise up? And if you run 1 step, let me change color. If you run 1 step, mathematically, I will say -1 step in here, right? This picture is -1. And then how many steps you can rise up? So here you rise up, looks like 0.5, right? And here you rise up 1. And you rise up 1.5. Here you rise up 1.5. You rise up. Okay, this. Okay, you say this. So we can see the scale here. This is 3. 1, 2, 3. So 1 is about this. So this is 1. This is 2. This is 3. This is 4. So how we calculate the slope for the first one? So slope 1 is when you have run 1 step, to the depth, we say is -1. Okay, if you go right hand side, it will be +1. So -1, and then you go up one step. So the slope will be -1 for first one. And the second slope, we say slope 2. When you walk to the left hand side one step, you goes up 2. So slope 2 is -2. Okay. And then let me change color so you can see better. Slope 3, when you run to the left hand side one step, you need to rise up 3 steps. So slope 3 is -3. Okay. And this one, slope 4, is when you rise up 1, 2, 3, 4. 1, 2, 3, 4. And you need to go one step. The picture doesn't look same scale. So horizontally, this 1, 2, 3, 4, 5. Okay. But here, vertically, this is 1. So a little confusing. I don't suppose to choose this graph. But still, this is a good graph. Easier for me to just post here. Now, so this is a definition of the slope. And I show you with, well, this is -1. So slope 4 will be -4. Okay. So that's the first example for showing you how to use the formula of the slope. Now, if you have this direction of the line, then for example, there's one step and the one step, pretend, then the slope will be rise over run. You run one step to the right hand side is positive, and rise up, so it will be 1. So this formula will tell you the idea of how you decide the slope. So if you want to climb the mountain, you won't go under the ground and go up. You won't do that. So if you have a mountain, you want to go climb up, you won't go here and then there, right? You will directly go from here to there. Then how you calculate the slope? You simply try to find the coordinate from x1 to x2 and from y1 to y2. You want to find the change of x. So run means change of x, and the rise means change of y. We use this symbol, change of y, change of x. So how much change on y, how much change on x? That will decide the slope for you. And you don't really need to go under the ground or the mountain and rise up. No, not that, just by calculation. Okay, you can use the coordinate. To calculate the slope. So next, okay, more examples here. So if you have a curve and if you go from here to there, definitely, I said that you have no way to learn how to find the slope for each way. Okay, so you need to pretend it's a straight line from here to there. Then you can calculate the change. But if you have a straight line, then it's easier. So I would like you to pay attention here. Let me erase the curve because we are not going to study the slope for a curve. But if you have a straight line, we can find the slope, right? You can find the slope, and you can see the slope are the same everywhere. Then how about if I make a triangle bigger, do we still have the same slope? So in this example, you can see that for the blue color, when you go part 1, you rise up part 1. So slope is 1/1 is 1. How about the green color? Green color, you go up, you run 2 steps, and you go up 2 steps. Same thing is 2/2, still 1. So that's why I said on the same straight line, no matter the triangle is big or small, rise over run is all the same. And how about if you make an even bigger triangle? Let's see this big triangle. Okay, so when you run 1, 2, 3, you run part 3 and rise up part 3 in this case. So the slope will be 3/3, still 1. Okay, so on the math equation, if you have a 9, how you find the slope? You simply find the coordinate, any 2 coordinates. You can choose any 2 points, and you have x1, y1, and you have x2, y2. No, x2, y2. Okay, so see, you have x1 here and x2 here. Let me erase too many marks here. Okay, say if we are looking for 2 points, if we are looking for these 2 points, okay, so right now I'm going to talk about the formula for the slope. So you have x1, x2, and you have y1 and y2 here. And then we try to make a triangle to help to calculate. So, oh, I didn't change the color. I'm supposed to change the color. Okay. So let me change it to green color. On this triangle, this is run, this is rise. So how many steps you run? 1, 2, 3, 4. How do you know it's 4? x2 minus x1. You probably want to make absolute value. No, you don't want to make an absolute value because we need the ratio, right? So the bigger number take away smaller number. Okay. And then so this is run. And the rise will be y2 minus y1. y2 minus y1. And the slope will be rise over run. So if you have run x2 minus x1, then you have to rise up y2 minus y1. And I have to tell you, this is a formula, and you need to group y2 and x2 together. If you put it in the front of the subtraction, you need to put them together. And the y1, x1, if you put after the subtraction, then you need to group them together. And this is totally one fraction. Okay, so we use a symbol. The change of y divided by change of x. That's the formula. Rise over run. It means if you run 3 steps, you need to write 3 steps in these examples. And the formula, you should memorize the formula here. Okay. So if we make the line more steeper here, wow, this line here, then you're supposed to find different slope. But you need to find the change your x, change your y, subtract. And then you can slope for this line. So this is the formula. Now, why you have to line up 2 with 2, 1 with 1? Because, for example, if you have this direction of the line, you know the slope need to be negative, right? Why is negative? Because if you run, for example, if you run 2 steps, then how you goes to here? Basically, you run 2 steps and go down, right? You go down, you don't go from here. Or if you want to go up, you need to go -2 and go up. Go -2 and go up. So you have -2 here and up 1, 2, 3, 4, for example, 4. Go up 4 is +4. So the slope become -2 in this case. Therefore, the coordinate will help you with the positive and negative. We are going to have more examples on the homework section and the homework video, homework PDF file. We can do all the calculations to help you with the positive and negative slope calculation. But by the concept, this direction is positive slope, this direction is negative slope, and how you calculate exactly positive or negative, you need to make sure you use the formula correct by grouping the same coordinate together. But right now, we want to keep going to next page. We want to use this formula to deduct the formula. So if I give you 2 points or I give you a graph, you can find the slope. And furthermore, I would like you to find the equation of the line. That's very nice. When you have slope and you have, if you can find at least 1 point, okay. Now I want to review some concept of the geometry for you. If you have only 1 point, how many lines can go through this point? Many lines. But if you have 2 points, then it's already decided there's only 1 line can go through these 2 points. In other words, you need to have 2 givens to decide 1 line. So I need to give you 2 information. Either I give you 2 points. If I give you 2 points, then you suppose already decide this equation, so you supposed to are able to find the equation of the line with 2 points. Now this video, I want to concentrate on the concept. So how to calculate the equation with 2 points is not on this video. Just I talk about the concept. If I give you 2 points, then you suppose are able to calculate the equation of this line, and you can learn that from our review. Basically, you're supposed to learn from Algebra 1, but we can review this calculating skill from Chapter 7 homework. And if I don't give you 2 points, but I give you 1 point, then I need to give you slope. Anyway, I need to give you 2 information, 2 givens. Okay, and another formula is if I give you the slope and give you y-intercept, So if this point is very special, the x-coordinate is 0, then you suppose are able to find the equation of the line. So next part, I want to show you how to find the equation of the line if you have slope and at least one point. Okay, but I would like to stop the video for now, and the second half of the information I will use the second video to show you. Okay, so see you next time. Bye bye.